Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for maximum subarray problem. Let's look at the problem description. We are given an integer array nums and we have to find the subarray with the largest sum and return that value. Okay, let's take a look at the example 1. So in this case, the nums array has 9 elements. The sum of all the elements in the subarray, which starts at index 3 and ends at index 6, is the largest among other subarrays sum. That's why the output is 6. So in the case of example 2, the nums array has only one element, so the maximum sum of the subarray is 1. So in the case of example 3, the largest sum of the subarray is 23. So if we add all the numbers, we get 23. The constraints for this problem are the length of the arrays ranging from 1 to 100,000 and the individual elements value is ranging from minus 10,000 to 10,000. Let's look at the approach to solve this problem. We are given a nums array with 9 elements. So in this array, the subarray which starts at index 3 and ends at index 6 has the largest sum, which is 6. So that's why the output is 6. The brute force approach to solve this problem is we compute the sum of a different size subarray, starting from the subarray size of the actual array size and keep reducing the size of the subarray. For example, to begin with, we start computing the sum of all the elements in the given input array. Next, we reduce the array size to 8 and then 7 and then 6. So we repeat this until we reach the subarray size 1. And then we keep track of the largest sum seen so far. In this approach, we ended up having order of n square time complexity solution. But we can use the cadence algorithm to compute the largest subarray sum with order of n time complexity. Okay. So this algorithm uses two variables. One is the current sum and the maximum sum. The current sum keeps track of the sum of the current subarray. The maximum sum keeps track of the largest sum computed so far. Okay. And whenever the current sum computed is smaller than the value of the current element, then we reset the current sum with the value of the current element in it. For example, to begin with, we initialize the current sum and the maximum sum with minus 2. In the very first iteration, when we process the element at index 1, we add these two elements, so we get minus 1, but that is less than the actual value of the current element being processed. In this case, we update the current sum with this value. Okay, so we repeat this until we process all the elements in the array. Okay, as we traverse the array, we also keep track of the maximum sum computed so far. So whenever the current sum computed is greater than the maximum sum, we update the maximum sum with that new value. And finally, the maximum sum variable will have the largest subarray sum. That's what I have written here. First, we initialize the current sum and the maximum sum variable with the value of the first element and then traverse all the other elements in the array. And in each iteration, we update the current sum with the maximum value between the current element and the current sum plus current element value. Whichever is greater, we assign that to the current sum. And also we update the maximum sum with the largest value among the current sum and the maximum sum value. We repeat this until we process all the elements and finally we return the maximum sum. Let's look at the flowchart. Input for this max subarray procedure is the nums array. First we initialize the current sum and the maximum sum variable with the value of the first element in the input array, and then we initialize the index with value 1 so that we start processing the array from the second element. Each iteration we check whether the index is less than the length of the array. If that is true, then we update the current sum with the value that is maximum among the current element nums of I and current sum plus nums of I. Whichever is greater, we assign that to current sum. Next, we check whether the current sum is greater than the maximum sum computed so far. If that is true, then we update the maximum sum. Otherwise, we proceed to process the next element. We repeat this until we process all the elements in the input array, and then finally we return the value in the maximum sum as the output. Let's move on to coding. First, I initialize the current sum variable with the value of the first element in the input array, and the maximum sum variable with the value of the first element. Next, I write the for loop, and this for loop processes the element starting from at index 1. Each iteration, I update the current sum variable with the value that is maximum among the current element, which is at index I, and the current sum plus the current element's value. Whichever is greater, I updated that value in the current sum variable. This variable contains the sum of all the elements in the current subarray. Okay. Next, I update the maximum sum variable with the value maximum among the current sum and the maximum sum variable. Finally, I return the maximum sum variable. Next, I am going to run the test cases. All the tests passed. Next, I am going to submit this program. Cool, this program is accepted. Next, I am going to do the code walkthrough with sample input. We are given the nums array with 9 elements. In this array, the subarray which starts at index 3 and ends at index 6 has the largest sum, which is 6. That's why the expected output is 6. First, we initialize the current sum and the maximum sum with the value of the first element in the input array. So in this case, -2. So we initialize the current sum and maximum sum with -2. And then we initialize the index with value 1, so that we process the array starting from the second element. Okay. So in the iteration 0, first we try to find the maximum value among the nums of I and the current sum plus nums of I. In this iteration, the nums of I has value 1 and the current sum is -2. So 1 is greater than the sum of -2 plus 1, which is -1. So we update the current sum with the maximum value, that is 1. So that's why the value is changed from -2 to 1 for the current sum variable. And next we update the maximum sum with a larger value among the current sum and the maximum sum. So in this case, the current sum is greater than the maximum sum variable. So we update the maximum sum variable. Okay. Then we increment the index to process the next element in the array. So in this iteration, the current value is -3, and so the current sum plus nums of I is -2, and the current value is -3. So -2 is greater than -3, so the current sum is updated with -2. And next, the maximum sum variable is greater than the current sum -2, so it is not updated. Okay. Next, we increment the index to process the next element. Okay. So in the iteration 2, we process the element at index 3, which has value 4. So 4 plus -2 is 2. So the current element's value is greater than that sum. So we change the current sum variable's value from -2 to 4. Next, the current maximum value is less than the computed current sum. So that is also updated with the new current sum, which is 4. Next, we increment the index to process the element at index 4, which is -1. So 4 minus 1, 3. 3 is greater than current value at index 4. So the current sum variable is updated with the value 3. Okay. And the new current sum is less than the maximum sum. So that maximum sum variable is not changed. Next we increment the index to process the element at index 5, which is 2. So now we add the current element's value with the current sum. So now the current sum is 5, which is greater than the current element's value. So the current sum value is changed from 3 to 5. Next, the new current sum is greater than the maximum sum variable's value. So that maximum sum variable also updated with value 5. Next we increment the index I to process the element at index 6. So in this case, element at index 6 has value 1. So 5 plus 1 is 6, which is greater than the current element's value. So the current sum is updated with 6. Next, the current maximum sum value is less than the new current sum, which is 6. So the maximum sum variable is also updated with value 6. Next we increment the index to process the element at index 7, which has value minus 5. So 6 minus 5 is 1, which is greater than the current element's value. So the current sum variable is updated with value 1. Now the current sum value is less than the maximum sum variable. So the maximum sum variable is not modified. Next, the index is incremented to process the element at index 8, which has the value 4. So now 1 plus 4 is 5, which is greater than the current element's value. So the current sum is updated with 5. But the current sum is still less than the current maximum sum value. So the maximum sum variable is not updated. After processing all the elements in the array, finally we return the value in the maximum sum variable as the output, which has the value 6. That is an expected output. Next I'm going to do the time and space complexity analysis for this solution. The time complexity of this procedure is order of n. Okay, let's take a look at the case 1. The nums array has 9 elements. So in this case, this for loop performs 8 iterations. And in the case of 2, the nums array has only 1 element. In this case, this for loop performs 0 iterations. Okay, so if there are n elements in the input array, then the for loop performs n minus 1 iterations. So that's why the time complexity is order of n minus 1. After removing the constant factor out, the time complexity is order of n. The space complexity is order of 1 because we are not allocating any additional space in terms of the input size. We just use only 2 variables. That's why the space complexity is order of 1. Thanks for watching this video. Have a great day.